Hello, my name is Joseph Shackelford, and this is my Charge Tapes Revised presentation. So what is the lab? The lab consists of two pieces of tape, tape A and tape B. Tape A is used to make tape B float in the air due to the repulsion of objects of the same charge. And the purpose is to compare the point charge model to the line charge model. Use the tape to model electric fields and to demonstrate difference in accuracy between the models. Here's an overview of the results. The line of charge is more accurate when compared to the point charge model. The force of the electric field is equal to the force of gravity, which is 1.96 times 10 to the negative 3 newtons. And the charge on each tape is around 6.697 times 10 to the negative 9 coulomb. For principles used, we use Newton's second law, F equals ma, to calculate the charge on each tape, along with Coulomb's law, F equals charge times the electric field, to calculate the charge, same reason, and to use superposition to add all the charges up. So going on to the experiment. Assumptions that I made: the tapes are uniformly charged, air resistance is negligible, each tape has the same amount of charge, the tape is perfectly rectangular with no abnormalities, and the electrons are taken evenly throughout, and the tape weighs 1 gram per meter. So the creation of charged tapes is the same as lab 1. The system is tape A and tape B. This reminds of everything else. The initial conditions are two pieces of tape, tape A and tape B of the same length. Another piece of tape stuck to my counter, and everything here is neutrally charged initially. Details: tape B is pressed evenly onto the tape on my counter and quickly ripped off, stripping the electrons from tape B, leaving them on the table tape, creating a charged tape B. This process is repeated for the creation of tape A. These are the data and calculations from the first lab. So we used Newton's second law along with Coulomb's law, and we calculated the force of gravity, the net force, and we eventually calculated the charge from the tapes, treating them as a point charge, and that result was 8.4 times 10 to the negative 9 coulombs. So for the coding part, which is the whole lab 2, here's my glow script model. The first part is the electric field, is the function that finds the electric field, which we made in lab 0 and worked on a bit in lab 1. And then the second function is what creates a line of charges that gives us a more accurate estimation compared to a point charge. And so you see right here at the top, we call these functions twice, and it creates two lines of charges, one for tape A, one for tape B. Top tape is the tape that's being pushed up by bottom tape to try and cancel out gravity. And then we have the scale factors such that the arrows can look decent. So right here we have two for loops, one within another. And basically what it does is that for each point charge in the tape, in my case I have 10 in each tape, it calculates the force that is exerted on the other tape. So each point charge in another tape, it calculates the force exerted on one point charge to all of the charges on each tape. So if each tape has 10, it does 100 calculations. And right here is more arrow creation for the model, so you can visually see the forces and the cancel out in each model, along with the magnitude and the direction of each. Here we have two different charges being compared to each other. The first charge you see on the left is the charge that I collected in my first lab. It's much stronger than the second charge that I have gotten, and as you can see, the magnitude of everything is much bigger, much stronger. It's greater. The electric force is greater than the gravitational force. And in my second one, it's that which I calculated using this formula that we derived in the lecture from integrals and such. It is a lot closer to the gravitational force, and it cancels out a lot more. So model discrepancies and sources of error. The charges are likely not equal, and the charge may not be evenly distributed. Those are two sources of error. And model discrepancies, we found that the second model is more accurate than the first, and that while the second model isn't perfect, as it is a summation, not like an integral, it is decently accurate. So what ifs and whys? If I had modeled my charge based off of the point charge versus the line charge, it would have been less accurate, and there's a 21% difference between the two charges, which would have reflected on my data. And why do these charges and estimates differ? They differ because the line charge is more accurate and the tape is more realistically reflected by that, when the tape actually isn't a point charge, so it's less accurate. So conclusions, the line charge is more accurate in the point charge model. For me, the difference is more significant than I had imagined initially, and that the more segments an object is divided into, the more accurate the estimation will be.